Hello everyone, welcome to the lecture series of pattern classification. I am Kundan Kumar, and if you would like to have these lecture slides, you may refer to my GitHub page at this given link. So in the last lecture, I've introduced you the pattern classification and how it is related with the different domains like machine learning, artificial intelligence, and also I have discussed the few applications of the pattern recognition system, and I have given one example of a the fish classification problem, and there we discussed that how we can consider one or more number of features and how we can generalize our model so that the our model will work good on the unseen data samples. So in this lecture, I will talk about the pattern recognition system and design cycle. So before that, there are three different pattern recognition models. The first one is the statistical model. The second is structural or syntactic. Third one is the template matching. Okay, in the literature, you will find these three pattern recognition models. So what is the statistical model here? That if we find or we identify a very specific piece of items or belongings in an image or in any the data, okay, for example, suppose a cat in an image, a cat is there, and if it is recognized by the computer that yes, this is cat, or maybe you have images of dogs, so cat, dog. So means if the model is able to recognize the object, okay, then we can say that it is statistical model because it uses the statistical features. Okay, what are the distribution of the data in that uh, object. So in that case, a statistical uh, pattern recognition model identify the specific object in the image. However, the structural or syntactic pattern recognition model, it finds the complex relationship between the elements. For example, suppose we are recognizing the face, then in the face there is a strong relationship between the position of eyes, nose, lips. So the structural pattern recognition system will identify the position of nose and position of eye, position of mouth, position of lip. So these relations will be are correlated in the structural pattern classification to make the decision that whether the person is male or female, or to identify a particular person by their face. So we can have many other applications where we can apply the structural pattern recognition model. For example, in case of 1D signal like ECG signal, so electrocardiogram signal, it is a 1D signal, and you know that this is a periodic signal. And in this signal, uh, there are some features like PQ segment, RS segment. That means there are some peaks and trough. So need to detect those peaks and the distance between those peaks so that it is defined as the PR segment or QRS segment. So these are the basically the features of ECG signal. So based on the relationship between these segments, someone can, that means, or we can say that a doctor, specialist can tell us that that the person having some heart disease or not. So it looks for some structural relationship between the attributes. Okay, attributes or feature, you can say. Okay, there are many, the names are there that we call it. Okay, and the third kind of pattern recognition model we have, that is the template matching. So here we will have one template, or you can say that a sub image, and we can find that sub image in a very big image. So the sub image, you can assume it as a template, and we try to find this template in a big picture. Okay, so one of the best example is the plagiarism, because so we try to find the text which is already published, or already that means someone have uh, written those text. Okay, so that means it will check that whether some text are copied from the previously published documents or published articles. Okay, so here the template matching is used. So this here we use the basically template matching based pattern recognition model. So these three pattern recognition model visually you study. Sometimes you will find an application where the multiple type of the pattern recognition models we consider. That means a application where statistical and structural pattern recognition model will be combined to perform a specific task. Okay, this is our the pattern recognition system. Here we have many blocks, and these blocks are connected in a ordered fashion. Like first we need to understand the environment, a physical environment. Then the data is to be acquired using camera or microphone. Okay, the camera for the images or video, and microphone for the voice, speech, or any other one-dimensional signal. Then we pre-process those data to remove the noise or to eliminate some unwanted signals from the data. Okay, the data that we have collected from the environment. Okay, after pre-processing we extract some useful features, so that the feature which is very useful to segregate between the two or more classes. That means the features which have the distinguishable characteristics. So after feature extraction, we will have the features, and those features will be used for the classification. Okay, so before classification we should have a model. Okay, so that we can take or we can make our decision. Okay, so from the same environment data is to be collected to collect the training data, and then we perform the same pre-processing techniques. Okay, then feature extraction, and those features is to be used, okay, to create this model. And then this model is used to make the decision on unseen data. So suppose if we collect the data and we'll extract the features and we perform the classification, then this model will be used to make the decision. So maybe sometimes the output of the classifier is not used directly, then we do some we can do some post processing, and then we make the decision. Okay, so let us discuss each block in more details. Okay, so in data acquisition and sensing we use the transducer, okay, where the camera and microphone we can use. And then we measure the physical variables, okay, and when we acquire the data from the environment, then there are some issues like the bandwidth, resolution, okay, sensitivity, distortion, SNR, latency, okay. So these are the issues may come when we acquire the data, because suppose we are dealing with the wireless sensor network and the data will be sent from one point to another, then bandwidth will be an issue, okay. That means the data will be collected at one place and it will be transferred to the another place, then this bandwidth will be an issue. And if we consider the images, then we have to capture the good images. That means the images should have good resolution, the dimensionality of the images. Okay, so these are the important issue. Then the acquired data will be pre-processed. That means we will remove the unwanted noise. Okay, and then isolation of patterns of interest from the background. Okay, that means whatever the pattern of interest is there, we have to suppress the background noise. Okay, and then we can have the application like segmentation and grouping. Okay, in the pre-processing, so usually in medical image processing we perform the pre-processing, like suppose a CT scan images there, suppose we have lungs, then the people, what they do before analysis of the lungs, they segment the lungs image and then they extract the features. Okay, so in the pre-processing, people extract the people perform the segmentation and grouping. After pre-processing, feature is to be extracted. Okay, and that features, okay, the finding a new representation in terms of feature, that means whatever the data we have collected, that will be same, but the feature is kind of new representation of the data. Okay, and features should be well separated and should not overlap. That is the basically discriminative nature of the features. Okay, so this is very important. Invariant features with respect to translation, rotation and scale. So whatever the features suppose we are extracting, so it should be invariant to translation. That means if some object is at one place and if we pick up that object and we keep on the other place, still that object is to be recognized. Okay, because just we have moved the object, it is translated, but the object is not changed. So the recognition system should, that means whatever the features we are extracting from that object, it should be same. That means whatever the feature we are extracting at this place and at the replaced place, the feature should be same. Okay, similarly for rotation and scale. So depends on the characteristic of the problem domain, we can have the rotation and translation invariant features. And the feature should be very simple to extract and invariant to irrelevant transformation and insensitive to noise. Okay, so these are the characteristics of good features that we need to take care when we design our pattern recognition system. Then the model learning, okay, and estimation. So whatever the features we extract, from that we create our model and we estimate the some statistical parameters, some kind of distribution from the extracted features. So here we learn a mapping between features and feature group and categories. Okay, that means basically the model learns a mapping between the input feature vector and what is the target. Okay. And if we are unsatisfied with the performance of the classifier, then we have to choose the another model. Suppose we have chosen some model, okay, and if it is not giving good performance, then we have to change our model so that there will be a chance that the new model will give us a better accuracy. So once our model is created, then we perform the classification. So using the features learned model to assign pattern to a category. So as I told you, the feature vectors may be associated with some group or some label, okay, or some target. So if new features comes, then the new feature should be assigned to some category or some label uh, where we want to categorize the unknown data samples. Okay. Then we do post processing, and in the post processing we evaluate the confidence about the decision, that whatever the decision we have taken, whether that decision is our acceptable or not, how much accuracy we obtain. So these things we perform in the post processing. Okay. So as we design the pattern recognition system, in the same way we can have a design cycle. So in the design cycle we have loops, something like, suppose our model, so whatever the model we have chosen, and that model is not giving a very good result, then we change our model with the new one. So it may be possible the new model is not performing good. So again we will go back, okay, again we will go back and we will change the feature, or we can consider the other feature, or we can add more number of features, and we will check that whether our model is performing good or not. So here every steps are in basically in a cycle. Maybe if we are not getting good feature, our model is not working properly, then maybe whatever the data we have collected, that data is basically the full of error. Lots of error are there in that data, whatever the data we have collected. So again we have to collect the data. So this is kind of loop. So that's why it is called the design cycle. So in the design cycle, first we collect the data, okay, so collecting the training and testing data set, okay, then so how do we know when we have collected an adequately large and representative set of example for training and the testing? So in suppose we are collecting the data, and how would we know that we have sufficient data samples? Whatever the samples we have collected, is that data is sufficient to generate our reliable model? Okay, so those things here we can study. Okay, so that means we will collect the data, we will extract the features, then we will create the model, and we will check that our model is performing good or not. If our model is not performing good, then again we will go back and we can change the feature type, or we will increase our number of data samples. That means we have to collect more number of data samples. Maybe whatever the data samples we have collected, that data samples are not adequately large, or that data sample is not very good representation of the system. Okay, so in the feature extraction, so we can perform the feature selection. Okay, so domain depends on the prior information, okay, whatever the feature we extract. So it depends on the prior information, and it is very computationally costly and also feasible. Okay. The feature should be the discriminative features, because it should have the similar value for similar patterns and dissimilar value for different patterns. Okay. It should be invariant with respect to rotation, translation, scale. It should be robust with respect to occlusion, distortion, deformation, and variations in the environment. Okay. Then model selection, what type of model we can select during the design. Then domain dependence and prior information. If whatever the model we are selecting for speech recognition may not, it will work for the object detection in the computer vision. Okay, so it will be domain dependent. That means some prior information is required. Then the definition of design criteria, whatever the design criteria is given, based on that also we have to choose the model selection. Our model is parametric model or non-parametric model. Parametric, non-parametric means that whether the distribution is known to us or not. Okay, that means whatever the data samples we have, whether distribution of the experiment is known to us or not. Maybe we should have the parameters of the distribution, and it is possible that we don't have. Okay, sometimes we don't have features, okay, at some places. So those features are basically called the missing features. Okay, suppose we have to extract 10 features from each samples. Okay, maybe some feature will be missing for some samples. Okay, in that case also our model should work. So that means our model should work under the missing features also. Okay, it should be less complex. Okay, computational complexity should be less. Then the types of model. Okay, so decision theory, statistical model, syntactical or structural, neural or hybrid. So different types of model we have. Okay, so already we have discussed few models that is available in pattern classifications. We can know how close we are to the true model underlying the patterns. So how could we know, how we know that we are close to the ideal situation? That means whatever we want to perform, our model is performing at that level. Okay, that is the question. It is unsolved. Okay, so basically in the post processing we check, in evaluation we check whether our model is performing on the test data sample or on unseen data sample or not. So that kind of thing we can check for the model selection. Then we perform training. Okay, so how we can learn the rule from the data? So we have the different learning algorithms. Okay, we will see the different learning algorithms. Bayes decision rule are there, neural network, artificial intelligence. Okay, so here we have the different types of learning algorithms like supervised learning and unsupervised learning, and also we have the reinforcement learning. So in supervised learning, basically we train our model using the training data sample where the labels are known to us. Okay, that means a teacher provides a category label or cost for each pattern in the training set. So if suppose we are performing training, and if we know the labels of the training data set, that means we are giving some information of the class label associated with the training data set. So using that information, when the model will learn, so that model basically it is learned through the supervised learning. And on the other hand, if we don't have the labels, that means we have the training data without any labeled data, then that learning process will be called as the unsupervised learning. Okay, and unsupervised learning, the example of the unsupervised learning is the clustering. Okay, like K-means algorithm, K-method, okay, some agglomerative clustering techniques. And in supervised learning, we have learning, neural network, deep learning, okay, base decision theory, then K means, so they, K nearest neighbor. So there are many examples you will see in the lectures, okay. And the third type is reinforcement learning. And in this learning, basically, there is no teacher, okay. That means the teacher will not give you the exact information that this training sample belongs to which class. The teacher will be there only to guide you that if you are going on some path, so teacher will tell you that whether you are on right path or not. Okay. The teacher will not tell you that on which path you have to go. That is the major difference between the reinforcement learning and the other learnings. Okay. So basically in this case, some rewards are assigned to the decision, okay, and based on that rewards, the reinforcement learning learns by own, okay. So here the no desired category is given, but the teacher provides feedback to the system such as the decision is right or wrong. So only this information teacher provides here, okay. Then evaluation, okay. So we have to estimate the performance with the training samples, okay. We can estimate our the accuracy of the model or performance of the model using the test data samples, okay. So if our model is performing good on the unseen data samples, then we can say that our model is generalized, okay. So in the evaluation, we find the problems of overfitting and generalization, okay, whether our model is overfitted or our model is generalized or not. That means it works on unseen data or not, or only it performs good on the training data set. Okay. And also we compute the computational complexity. That what is the complexity of our algorithm when we design our pattern recognition system. So here we study that what is the trade-off between the computational ease and the performance. So we compare these two. Okay, always we try to make the trade-off between these two. Okay, and also we try to scale the algorithm, or we try to scale our model with respect to number of features, patterns, or categories. Okay, so these are the differences of supervised learning and unsupervised learning, semi-supervised learning, and reinforcement learning. So already I discussed in the design cycle. Okay, so here these two are very close to each other. Okay, but in reinforcement learning, basically we have some rewards. Okay, the reward function we compute, and based on that it makes the decision right or wrong. I hope I'm clear to you. If you have any doubt, you can ask in the comment section. Thank you.